Alright, good evening and welcome to Maths and Talker online class. Today we'll be talking about the Moivre's theorem. We use this theorem when when you want to find the power of a complex number. For example, if you have that z is equal to maybe x plus iy, and you're asked to find maybe z raised to power 4 or z raised to power 3 and so on and so forth, something like that. Okay, when we want to find the power of z, that is when the power we are talking about is a positive integer or a natural number. So but look at this law. The law said that if you have a complex number that is being multiplied by another complex number in their polar form, okay, in their polar form, all you need to do is just to say the modulus times the modulus, bring them outside, then in brackets of cos theta 1 plus theta 2, like this, plus I sine theta 1 plus theta 2. Okay, so that is that. Then if they are many, maybe z1 times z2 times z3 times z4, is as simple as saying bring all the modulus together, multiply all the modulus together. You now say cos bracket theta 1 plus theta 2 plus theta 3 plus theta t, where they get to. Okay, plus I sine, the same thing, you bring them together. Okay, then finally the last but not the least is now z raised to power n. Okay, where n is a positive integer. Okay, I'll still do for the nth root, okay, of it. Okay, so now the power n shows that what, that this is the polar form raised to power n. Then share it for them. It means this one will be raised to power n and this one inside it will equally be raised to power n. But what you do is you bring the n to multiply the argument, the theta. So it's going to be what, r raised to power n bracket cos n theta plus I sine n theta. Okay, forget about let me show you how. If I solve question, you understand. When I solve question, you understand what I'm trying to explain. Okay, so the first question we are going to look at says they said evaluate okay they said evaluate cos 20 degrees plus I sine the same 20 degrees. Okay, is being multiplied by cos 40 degrees plus I sine 40 degrees. Okay, please note that when you apply this law is when you are having that the argument is the same thing. If you have 20 here and have 10 here, please don't apply the law. They must be the same thing like this, and this one must be the same thing like this. Okay, if it's cos 30, it's going to be plus I sine 30. That is when you apply the law. So this thing is simply, this is equal to what, cos, you will not say what, cos go to cos, you say what, 20 plus 40, okay, plus I sine 20 plus 40. So what do we have? We now have cos 60 plus I sine 60. And according to the special angles, cos 60 is half. I hope you know. Okay, cos 60 is half. So this is equal to what? 1 over 2 plus what? I root 3 over 2. Okay, so that is that. If you don't know how I got this, go to my video on trigonometry. You will understand that. Okay, so that is number one question. Number two question, number one. Number two said evaluate evaluate 2 in bracket of cos 30 degrees plus I sine 30 degrees, then everybody raised to power 8. Okay, so what do? It's as simple as the argument first, the modulus first, the 2 will be raised to power 8. Okay, then this one will now be what, cos 30 times that 8, okay, plus I sine 30 times that 8. As simple as that. You see, it's very, very simple. So what do you have now? 2 raised to power 8 bracket cos 3 times 8, 24, 240, plus what? I sine 240 degrees. So let us get that. Okay, now 240 degrees, we can bring it down. Can we bring it down? Yes, we can bring it down to be 240 is in what quadrant? Let's check. 0 to 90, 90 to 180, 180 to 270. Okay, 270 to 360. So this is the third quadrant, and I have my cast CAST. So only tan is positive in the third quadrant. So which means each of these is negative. So if you want to bring this thing down from third quadrant to first quadrant, you apply the law then. If you don't understand, please go back to my video on trigonometry, you understand. So this is equal to 2 raised to power 8 is here, bracket. Because I want to change this thing to first quadrant, I'm going to say minus cos. Please, we don't use 270. You will say this angle here minus 180. Okay, plus plus minus is minus, minus I sine the same 240 minus 180. So I'm going to have 2 raised to power 8 bracket minus cos 60 minus I sine 60. Okay, the reason of this minus is because in the third quadrant only tan is positive. So my final answer for that becomes 2 raised to power 8. You can find what 2 raised to power 8 is, bracket minus cos 60 will give you what? Minus 1 over 2. Okay, minus root 3 over 2i. Okay, so that is that. In fact, this is another way of changing from a polar form to Cartesian form. Okay, so we're still going to get to something like that. Okay, so that is the second question we are going to solve. So the third question we are going to solve said the third question said that the third question, which is I plus root 3, sorry, 1 plus root 3i all raised to power 12. Okay, so how do we get this? There are two methods of getting this, and I'm going to show you the two methods. The first method is using the special angle table. If you look at root 3 is part of special angle, and if you remember your special angles, let me just take you back a little bit to that. This is theta, this is sine theta, and this is cos theta, and this is tan theta. Okay, and I have 0, 30, 45, 90, 60 and 90, 60 and 90. Okay, and how do you find this? It's very simple. The sign will help us to find it. Just say here, just say 1, okay, 2, 3, 4, 5. Did I get that? Sorry, 0 from 0, not 1, sorry, from 0. You are starting from 0, sorry. This is 0, 1, 2, 3, 4. You will now come back like this again. 0, 1, 2, 3, 4. Then make everybody over 4, 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 and over 4. Okay? So then find the square root of everybody. Square root of this, 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 and that is the answer. So which means sine 0 0 divided by anything is 0. So I'm having that here will now turn to 0. So the answer to this one has given us what? 0. Please don't forget how I got that 0. Okay. So the next one is what? Root 1 is 1. Root 1 is 1 and root 4 is 2. So sine 30 is 1 over 2. 1 over 2. Okay. Now root 2. Root 2 does not have a perfect root, but root 4 is 2. So this thing is saying reduce the root. Root 2 over 2. Root 2 over 2. Okay. So root 3 does not have a perfect root, but this one has a perfect root. So it's going to be what? Root 3 over 2. Okay. This one is 0. 0, 1, 2, 3, 4. Okay, 4. 0, 1, 2, 3, 4. Did I get that? Okay. 0, 1, 2, 3. Okay. Yes. So I'm having here what? What am I having? 4 divided by 4 is 1. Root 1 is 1. So my answer here is 1. Correct. So let's go here again. 0 divided by anything is 0. So root 0 is still 0. So here is 0. This one will give you 1 over what? 1 over 2. This one will give you what? Root 2 over 2. This one will give you what? Root 3 over 2. This one will give you what? 1. So to get the last part, you start dividing. This divided by this. 0 divided by a number is 0. But a number divided by 0 is undefined. So divide. This divided by this will give you root 3. You can do the division. When something divided by itself, I'm having 1. Then this divided by this will give you 1 over root 3. Okay, so that is that. Now, if you look at this, look for a number that will give you. I'm trying to use this to solve it before I show you the normal method. Okay, look for a number, look for a sign that will give you the same thing. For example, now I'm having root 3. Where do we have root 3? Okay, we're having root 3 here. Any other place do we have root 3? For sine and cos, these are the only places we have root 3. Okay. Okay, that's root 3 over 2. Okay, root 3 over 2. So let me put over 2 here and see what will happen. So this thing is saying 1 over 2. I'm putting over 2 for everybody. Plus root 3 over 2. Then all raised to power what? Bracket 2. Please let me bring out the same 2 outside so that 2 times this, it will give me back this. 2 times this, it will give me back this. Then everybody will still be over what? 12. So this thing means what? 2 raised to power 12. 2 raised to power 12 in bracket of. Do you know that for 1 over 2, what will give us 1 over 2 is sine 30. Are you seeing that? Okay, sine 30 will give us 1 over 2. Okay, so this is sine 30. But our trigonometry, our complex number is cos first before sine. So cos what will give us 1 over 2? Cos 60. Cos 60 will give us 1 over 2. So let's change it to what? Cos 60, okay, plus I sine 60. Yes, because sine 60 will still give us this. See how I got that? All raised to power 12. Okay, so don't forget that this one is still raised to power 12. So my answer becomes 2 raised to power 12 in bracket of cos 12 times 60 plus I sine 12 times 60. Okay, so I'm going to have 2 raised to power 12 in bracket of cos 12 times 60. So 12 times 60. I'm having 720 plus I sine 720. So if you look at 720 has exceeded the 4th quadrant. So how do you bring it back to any quadrant? Is by subtracting 360. Because just say 270 minus 360. You're having 360. 360 minus 360. minus 360. So I'm having 0. So this is cos 0 plus what? I sine 0. So what do we have now? Okay, so what do we have? So this is equal to what? 2 raised to power 12 in bracket of 2 raised to power 12 in bracket of am I making mistake? Okay, yes. Cos 0. What is cos 0? Cos 0 is 1. So I'm having bracket 1, okay, plus I sine 0 is 0. So 0i. So this is my answer. So which means I'm having finally 2 raised to power 12, because anything times 0 is 0. 1 plus 0 is 0. So you now have 2 raised to power 12 times 1, which is 2 raised to power 12. And that is the answer. Okay. So that is the second example. So now let's go to the third one. Okay, sorry, alternatively, another method you can use to solve that. Another method you can use to solve that is by using your changing it from Cartesian to polar. Let's change it from Cartesian to polar with the normal method we know. Okay, if we use the normal method we know, the question says I plus root 3i, sorry, 1 plus root 3i all raised to power 12. Let's change what did 1 plus root 3i. Let's change that. How do you change it? The first thing you get is your polar form. Sorry, your modulus. We want to change it to polar form. Modulus is equal to r, which is equal to what? The square root of 1 square plus root 3 all square, which is what? The square root of 4, which is what? 2. Our modulus is 2. Okay, so the next thing we're going to get is our argument. Our argument said that tan, but before getting our argument we need to draw it. In fact, since they are positive, it is first quadrant. But if you have forgotten, draw it. This is positive and positive, first quadrant. So my theta is equal to what? Tan inverse of y over this. So root 3 over 1. Okay, which is what? Tan inverse of root 3. And tan inverse of root 3 is what? 60. So I have gotten my argument to be 60. So which means this thing is equal to, so this thing is equal to r. Don't forget that z is equal to what? R bracket cos theta plus what? I sine theta. So what do we have? R is what? 2. 2 bracket cos 60 plus I sine 60. Okay, so but what we are looking for is the one that is raised to power 12. We are looking for the one that is raised to power 12. So if we say that z raised to power 12 should be equal to what? This thing that we have gotten, which is this thing that we have gotten, which is what? 2 bracket cos 60 plus what? I sine 60. Okay, so all raised to power 12. So which is what? 2 raised to power 12 bracket cos 12 times 60 plus I sine 12 times 60. Okay, so which will give you 2 raised to power 12 in bracket of what? Cos 720 plus I sine 720. So which gave us what? 2 raised to power 12 bracket cos 0 plus I sine 0. So which gave us what? 2 raised to power 12. 2 raised to power 12 in bracket of what? 1 plus 0i. So and our final answer is still 2 raised to power 12. You see, we got the same thing. So you can solve it. In fact, me, I prefer like this. If I change it to polar form first, then I can now apply this law instead of thinking of what you may not really get the answer accurate. Okay, so but the other method is faster. But if you know this one very much, before the person will think of those special angles, you have gotten what you are looking for. So so solve this for me. This one is and that is that. So in our next video we'll talk about the nth root of a complex number. So this question says 1 plus I all over 1 minus I all raised to power 10. Okay, so the easiest way to do this is just to rationalize. If you rationalize here, anything you get, change that into polar form, and then if that thing is still in complex number, you change it to polar form. Then from polar form you can get your answer. Okay, so that is that. So another thing I need you to understand is that there is something that is called cis. S-I-S. Cis. Cis of theta means, look at cis means cos c cos theta plus I sin theta. I sin theta. So they can tell you to find, in exam you can see find 6, find 6, 60 for instance. So it's equal to saying what? Cos 60 plus what? I sin 60. Okay, so which is what? Cos 60 is 1 over 2 plus I root 3 over 2, because sin 60 is root 3 over 2, and that is the answer. So don't forget that 6 means cos plus I sin theta. So that is that. Thank you very much for watching. In our next class or next video, we'll talk about the nth root of a complex number.